Um, I'm pumped. Anyone else pumped? That girl's pumped. Okay, today the goal is to make sure you're ready for tomorrow. If you didn't get a blue sheet, then you should have. It's right there on that table. Yep. Okay, today would be a great day to make sure you pay 100% attention. I have decided, because I'm just in a good mood, I guess, that I will not give you multiple choice on this test. Yeah. So some of you will finish this test in under 25 minutes probably. Some of you will take forever. It is designed to take one class period. So when you wonder tomorrow, am I going to give you class time if you didn't finish? The answer is for sure not. Yes. Okay. I said, hey, if you want a practice problem, take a picture of this and do it. All right. How many of you did this practice problem? Post came in and checked her work with me. Liam. All right. So I did the same thing in first hour. 4 people practiced. Whatever. This is kind of hard to follow, but these were your volumes. So that's where I got this number. Can anyone explain to me why this number here is twice as much as this one? All right, because there's a subscript here, which means when this breaks apart, it will be a 2-to-1 ratio. So the concentration, once it breaks apart, of NO3 is twice that of Hg. All right, well then why are these the same then? Tell your lab partner. Because there is no subscript. All right, good enough. All right, so those numbers came from there. The limiting reactant we found because we said, is this number right here? Because we find the bigger coefficient, and then we take its moles, and we say, all right, is 0.5 at least 2 times bigger than 0.24? That was yes, which means this other thing is your limiting reactant. That's how we discovered that. The next step, we would take our 0.25 moles, now that we know this is our limiting reactant, and we do a picket fence. This one ended up to be a 1/1. All right? And then we had 1 mole per 271.5. That's the molar mass of what our precipitate was. Oh, by the way, I knew this was the precipitate because Na and NO3 never form precipitates, so they're always spectator ions, right? All right. Then we're off to the races. The last things to do is just to find the concentration of all parts. The concentrations of all parts, the Hg was in both the limiting reactant and the precipitate, so its concentration was equal to 0. We'll come back to this in a second. The 2 spectator ions, you just take their initial concentration and divide it by the total volume. So 0.5 over 0.9 was this. 0.48 divided by 0.9 was that. Now, to find the chlorine, you take 0.5 and you subtract the used. The used, we have that fancy little thing we wrote yesterday. But if you'll look, every time we use one of these, it's twice as much as one of those, right? Or 1 to 2. So we plug that into that thing we did yesterday, and we end up doubling the 0.24 of our limiting reactant because we double 2-to-1 of our limiting reactant. So 2 times 0.24 is 0.48. So 5 minus that divided by 0.9, you end up with 0.2222. And I don't know why I went sideways. Last year, this must have been bigger and all the way to the side. And then we'd be ready to roll. Okay? The only person that came in to check had it correct. I don't know, that was a real good feeling, right? When you get these, finally, it's like a super good feeling. All right. This is the one we did first hour. It was quite a bit harder on accident, but whatever. If you would like to look at that sheet, you can stay during beat time. This is just me working through it on paper. This thing, my first hour, and I think you yesterday, a lot of you liked this. If you haven't written this out, this is a useful way to find the amount used. Oh, that's quite the rectangle there. The used can be found by taking the moles of your limiting reactant. That's from your volume times your molarity. And you multiply it by the ratio of your excess reactant coefficient divided by your limiting reactant coefficient. All right? That's what I did on the previous one. That's what I did when I did this in first hour. Super glad I didn't give this to you. This one was a pain in the butt. But whatever. The only thing, by the way, that makes this a pain in the butt was when you balanced it, there were no ones. So you just have to do a lot of ratios. And it's not that bad, but it does make it harder. Okay, so if you are interested in looking through this problem and working through it independently, that would be great. Feel free to come in. This is going to move the whole thing just for me to hit save. Let's do this again. I remember why it was that way now. Okay, we all right with that? Good. Now let's talk through this review sheet after we look at my kid on a slip and slide. It's definitely time to change it, right? I have their Halloween pictures. I should put those up. It's definitely not slip and slide weather anymore. Okay. I wish it was slip and slide weather also, because that would mean I wasn't working. Oh, sorry. Never mind. You like Halloween weather better? No, I don't. Don't ask me. Okay. Okay. Well, reason number 5, she doesn't like me. I don't like Halloween. Okay. Riesbach and I can be friends then. Yeah, I'm not. I think it's the stupidest thing ever. Okay, here we go. Here's your test review. So you should have these first 4 pages. And wow, this is a slow program. There should be. We can look. Why on earth is this so slow? Come here, computer. I'm just changing pages. There we go. Okay. So, some of these things in this top part are from the reading. If you're like first hour, then 3 of them said they read this entire chapter. I don't feel bad when you get problems wrong that you're not putting the effort in to learn. Okay, so first, you have to be able to use the term solute, solvent, and electrolyte to describe a solution. For 30 seconds, tell your lab partner, what is a solute? What is a solvent? What's an electrolyte? And what is a solution? Ready, set, go. Super easy. All right, so don't panic on dilutions. We'll go over them. All right, calculate molarity given grams. I do not have a practice one on this sheet, I don't think. So let's just review. We did it for about 5 minutes. Molarity from grams. You have to take your given grams, divide them by your molar mass. Bless you. And that would give you the moles of something, right? But we want molarity, so then you divide it by your volume. And that will give you your molarity. So if you have 30 grams of NaCl in 60 milliliters, you would take 30, divide it by 58.5, and divide that answer by 0.06. 0.6 liters, and that would be your molarity. Tell your person next to you, where did the 58.5 come from? That's the mass of NaCl. Where did the 0.6 come from? That's what this is in liters. All right? And the 30 was the given. So divide your mass by the molar mass and divide your answer by the volume. Okay? We've been using molarity a lot. We haven't had to calculate it too much because it was given to us. But there. Yes, from the volume. Well, no. Okay, sort of yes. You have to find the molarity of all the ions at the end. But the molarity is given to you. You only have to do this on one specific problem. And it's before the long ones. All right, you need to be able to have or show a basic understanding of redox reaction. Redox reaction is when something gains and loses electrons. You need to remember which one is oxidized. The oxidized is the loser, so red must be gain. Are we okay with that? Yes, both are acceptable. But don't write that on your AP test or your test. Well, you can, but don't write that as an answer. Because no, but I've seen a kid write that before. Like, what's oxidized? Leo the Lion says grr. Like, that's not an answer. That's a limerick to help you remember how to find the answer. Okay, this part, we've spent most of the first half of this unit, working on writing and balancing precipitate, acid-base reactions, and redox reactions. So you have to do one or two of each of those. I think there's 4. I thought there were 3, but there's 4, if I remember. I looked at the test this morning. Now, remember your red flags for when they react with an acid. And remember, the red flags only apply when we're reacting something with an acid. What are your red flags? Do you remember? CO3 minus 2, SO3 minus 2, S minus 2, and HCO3 minus 1. Good job. Now, a lot of you said things at the start. That's fine, but we're just looking for the anions that are the red flags, because they could be attached to a lot of different things at the front. Remember that these two here create CO2 and water, but this is only when they react with an acid, remember. SO3, when it reacts, it makes SO2 and water, right? And this is a gas right here. And then sulfide, when it reacts with an acid, it makes H2S, which looks like a different acid, but remember that is a gas, hydrogen sulfide gas. So there's at least one on here, and I'm pretty sure there is only one, but just try to remember. All right. Your precipitate, you will be given the solubility rules. You can find them on the paper I gave you. The solubility chart you will be given is this. It's the same thing that's printed on your blue paper. Okay? So you need to know how to use it, but it's given to you. All right, then solution stoichiometry. That's one big math problem. And then this is my favorite question of the test. I love it. And it's challenging. It will definitely demonstrate who understands what's going on and who is struggling with what's going on. All right, so it's just an application of lines, but you're applying it by looking at lab data, which is exactly how the AP test is. Practice one of these that we will do in 10 minutes. All right, and then an activity series problem with justification. On the test, you have to justify a lot. Up here, when you write and balance, you're going to have to write it out and balance and answer a question. That's like the most points people miss are usually in this section because they don't answer the question after they balance. They just forget about it and move down. All right. So these are the concepts. If you're solid on these, you should be fantastic and ready. So we will do this at the end if we have time. But the next page is just one more example of a solution stoichiometry problem that you can work through. And hopefully we have time at the end and we can get through that thoroughly. Sound okay? Okay. The next page then. This is the question that I absolutely love. There's a homework problem like this if you want another one to practice after. It says, number 2, whatever. You know that 3 unlabeled bottles, A, B, and C, each contain one of the following solutions. This sounds a lot like bottle bewilderment, which was the lab we did to start this whole mess. The 3 solutions are AgNO3, CaCl2, and Al2SO43. You perform an experiment by adding barium nitrate and sodium chloride to each and get the data below. What is the solution in each bottle? Justify your answer. Tomorrow, do not forget to do that part. You must justify your answer to get full credit. The answer will be worth 2. The justification will be worth 3. All right. I gave my first hour 6 minutes, so that says 9:10. So we'll go to 9:17, and that will account for wherever we are in that 10th minute. Will you work with your lab partner rules and see if you can figure this out? All right, here we go. The answers, and we'll work through the process here in a second. Oh, that's trash. Hold on, let me turn that other light off. So on the screen are answers in my handwriting, so that might not be helpful, and justifications. Bottle A, I don't know, I didn't go in order. I just went in order of how easy they were personally for my brain, so whatever. But bottle A is Al2SO43 because SO4 minus 2 forms a precipitate with Ba. I should put +2 right there, but not with Na. So that would account for why there was one in one box and wasn't one in the other. Bottle B has to be AgNO3 because Ag plus forms a precipitate with Cl minus, but not with SO4 minus 2. Bottle C, you can't just justify it, by the way, because the other 2 were those. You have to justify it based on science. Because Ca plus 2 and Cl minus form, this is a dumb way to write it, but whatever, form no precipitate with Ba plus 2 or N. Okay? I looked at 3 or 4 and you had them right. How many groups had those right? Raise your hands. Well, that's phenomenal. The one on the test will be very similar but different. And I don't know that I'll spend a ton of time because you guys got it right. But the fast way to do this, cross out what you know will be spectator ions, and then go hunting for exceptions. So you see Ba right there. Find Ba. It's right here, and right there. And then you look. Was hydroxide involved in this problem at all? No. So you don't need to worry about that. Was S minus 2? No. So it is here. So BaSO4. So it forms a precipitate. That's how you know A had to have SO4 minus 2. All right, then you find chlorine. Chlorine is soluble except for AgH+. This wasn't there, this wasn't there. So this is how you know this one has to have. That's how you would know those 2, and then you should double check. There's no precipitate, but that's how you would know the 3rd one. Does that make sense too? Yeah. Okay, thank you. Love how excited you get. All right. Well, I love how excited you are about my excitement about your excitement. Let's end it there. All right. Number 3, A and B. So here we A. See what happens. Whatever. One where you do have to apply the activity series. All right. Will you try number 3A for a few minutes, and then we will do B. Here. All right. Well, I won't talk it out, but I'll write it out. How about that? I will talk it out in a minute. No, it's reduced. Yes. Because it comes out as a lone element. So it acts sort of like a precipitate and just falls to the bottom. Post, you're probably thinking it right. You just got to remember the thing we're exchanging is a negative thing. Is that not what you did wrong? Is that not what you did? Okay. All right, I'm going to talk through this one. I've written it out. I have not balanced it yet, I guess. There's a 3 there, a 1 here, a 1 here, and a 3 there. Okay, now we need to look at what is happening. Aluminum goes from a 0 because it's in its element to a +3. If you became less negative, that means you lost electrons. And if you lost electrons, you oxidized. Okay, so from 0 to +3, you're moving away from negative, which means you lost your negatives. Ag goes from a +1 to a 0, or closer to negative, which means it gained an electron, which means it is reduced. You okay with that? On the test, I'd no longer ask you to explain how balancing the reaction helps explain the overall oxidation reaction. So don't worry about that. But just remember, we would always say, hey, the electrons have to equal each other. When we balance it out, that does happen. Because 1 loses 3 here, and 3 will gain 1 up here. Okay, so that's an oxidation reduction test where you have a metal replacing another metal in a compound. Okay, we all right? Okay, let's look at the one below it. So, which of the reactions will not happen as written? Remember our little saying, the lone element must be where? Higher than the other. Is that not right? If the lone element is higher, the reaction happens. We wrote it somewhere on your notes if you're a note writer. It's on a different set of slides, so I can't go back and look it up on here. Okay. At letter A, iron. Iron is right here. Then you find the ion, which will be lithium and chloride. So you're finding lithium. Lithium is here. Is my lone element higher? Definitely not, right? So A, this reaction will not happen. Okay? If we wrote it reverse, it certainly happens. Okay. Acid is dripped onto a small piece of barium. So barium is my metal now. It's my lone element. But acid, do you remember what acid, which one of these it is? Good. Acid introduces hydrogen to the equation. Is my lone element higher than my ion? Yes, so the reaction happens. Letter C. Copper is placed into a silver nitrate solution. Will this happen? So copper is here. My ion is here. They're close, but it is copper, yes, is higher than silver, correct? So the reaction will happen as written. Are you okay with that? You will be given this exact activity series on your exam. The exact same one on this sheet. Okay. Number 4.82. This is just a problem from your homework. We're only going to do the A part. We don't need to do the B. Don't worry about that because I'm not going to give it to you in grams. It's fine, but that just takes too much time. Okay. How to do titrations or dilutions yet, but I am going to in the next 4 minutes. I want you to write this little sentence out. So we're going to multiply and divide by the loner. Write that out either in notes. Okay. In a titration or a dilution problem, which you can read about in the textbook, you end up with a math equation that essentially, math-wise, just says, hey, A times B equals C times D. It's a 4-variable equation where you're asked to solve for one. So if I asked you to solve for D, you would simply take A times B and divide it by C. Correct? All right, so please look at what this sentence is saying. It's saying to find this unknown, we multiply the pair and we divide by the loner. Now let me add one little thing here. The pair are the two numbers that are connected by the word of. So now we're ready. We look at letter A in 4.82. How many milliliters of 0.120 molar HCl are needed to completely neutralize 50 milliliters of 0.101 molar barium hydroxide? So what two numbers have the word of between them? 50 and 0.101. What number is not involved in that? 0.120. So to solve this problem, I simply multiply the ofs and divide by the third number. So 50 times 0.101 divided by 0.12 is 42-ish, if I remember right from last hour. All right, then what unit would you put on it? Milliliters, because it asks for how many milliliters. They are very easy. What? Because it's okay. I was like, what? It's easy. All right. Would you like to do another example? Okay. I'm going to erase all this. How many milliliters of 3 molar HCl are needed to completely neutralize 5 liters of 0.5 molar solution. Why don't I write numbers that I can just do in my head? This is stupid. I can. 8.33. 0.833. I was close. I know. That's why I said don't be angry. This was a molar, huh? Sorry, that was confusing.
Really good at those.
Yeah. So when you go to college, say, I want to major in titration chemistry. They'll be like, oh, I have a class for you. It's called multiply the pair, divide by the loner. Yes. Okay. So there's one of these tomorrow. Don't panic when you see it. Find the 2 numbers of ofs, multiply, and then divide by the next one. Easy enough? Okay, good. Next. Oh, hey, not next. Is that it? Oh, okay, going back. I have 9 minutes. Would you like... 4 minutes, but I can talk through it in 4 minutes. How about that? Okay. Fire away, my friends. Ionic is just the formation of your precipitate. The moles of each where you since iodine, oh boy, that really messed me up. Since iodine is in both the limiting reactant and the precipitate, it is 0 molar. Both of these are my spectator ions. So I have NA's initial was 0.15. The new total volume is 0.8. You get that. I got to hurry. That's how you get that. The PB is initial minus used over 0.8. You take 0.1 and subtract 0.075. 0.075 came because you had 0.15 and then you had 1 and 2. So you divide it in half. That's the amount used. Okay, those come from the coefficients up above. The 1 from right here. 1 to 2. 1 to 2 ratio. So that's why that's why 0.15 got divided in half. You subtract that. This was a 0.025. I did that wrong. And then you have 0.8 and you get 0.03125. Okay. B time is right now, yes.